All right, so let's get started with transformations, which shouldn't be completely new to you. With transformations, we have four different types, but today we're just going to go over to the horizontal and vertical. So you're given a parent graph. Our parent graph for this one is x squared. And the transformation is that we're adding 1 within the x. So because it's grouped on the inside with the x, that lets us know that we're moving horizontally. Because it is plus, we know that we're moving to the left, okay? The weird thing about the horizontal is it's kind of the opposite of what you would think. So when we talk about the transformation, it would be a shift left 1 unit because it was plus 1. So if we were to draw it on our graph, we can move the vertex over 1, we can move this dot over 1, and move the other over 1. You don't have to do every single point. It would be beneficial, however, to look at it on your calculator and see the shift because, of course, mine definitely won't be perfect, but you can see that there's a shift to the left when I do it the second time. So for the next one, we have an exponential function. It's 4 to the x is our parent graph. And coupled with the x right here, we have a minus 5 there. So because it's with the x, we know it's horizontal. And because it's minus, we're moving to the right. So we would say shift right 5 units. For the last one, for the horizontal, we have a linear. Linears are kind of weird because they're both horizontal and vertical. But since we're talking about horizontal, we can look at it from that standpoint. So our parent graph was f of x is equal to x. And our transformation is we're subtracting the 4, which means that we're going to the right. Right, 4 units. So I'm going to start far over like about here, so we'll have some space. And I'm going to move this to this point right here, 4 units to the right. 1, 2, 3, 4. So that point will come here. And because it's linear, all I need is 2 points. So I move that point. Now let's move another one. How about the next one right here? And I'll move that over 4 points. 1, 2, 3, 4. So now my line looks like this. So that's that shift right. For the next one, we'll be talking about vertical, which is up and down. So you notice before it was coupled inside with the X, now it's on the outside. So that's a big difference that you want to make sure you take note of when you're looking at different transformations. So for this one, because it's on the outside, our parent graph was x squared, and we're going to move it down 2 units. Okay. So I'll start with my vertex, and I'm going to go down 1, 2, which is about here. And I'll do the same thing with the other 2 points, 1, 2, which is about here, 1, 2. So my new parabola looks like this. And again, it's not perfect, okay, but you're moving down 2 units this time. So you would describe it as shift down 2 units. For the next one, we had the same exponential. But it should say in your notes, I'm sorry, my thing is a little messed up. It should say that you have f of x is equal to 4 to the x minus 5, okay? So it shouldn't be coupled up there with the x. It should be at the bottom, okay? So because it's not coupled with the x, our transformation will be a shift down 5 units. Okay, and again, this is what it should look like in your notes. Okay, for the last one, we have the same one. This is why I said that linears are kind of weird, because they mean the same thing. Really, you can't really tell whether the -4 is coupled with the x or whether it's just on the side. And actually, whether you describe it as shifting 4 units to the right or shifting 4 units down, it's still going to look the same. And I'll show you how that happens. So this time we can just take this middle point and bring it down 1, 2, 3, 4. And then I'll take another point. How about this one? 1, 2, 3, 4. Okay, so these are my new points, and I'll just connect the dots. And you'll see that it still looks the same whether you shift down or whether you go to the right. So that one, I'll describe it as shift down 4 units. But it's still the same